Hey, today we're going to talk about solubility, and I'm going to explain how much solute you can actually dissolve in water at a given temperature. Before we begin, I need you to get out your reference tables. Turn to this page. We're looking for table G. It's on page number 3 of your reference table. Now, this table, even though it looks a little confusing, there's a lot of information on here. But really what it's explaining is it's telling us how much solute you can get in 100 grams of water. This right here is 100 grams of water. And as you probably know from your own experience cooking or boiling water, is that if you heat up water, you can usually dissolve more solids in the water. Most notably, you can get sugar dissolved in water at a much higher temperature. So as you increase the temperature of the water, you can actually dissolve more and more sugar. In fact, this diagram, these 3 diagrams are showing you how solubility, or the 3 different types of solutions. What we have here on the top, which we have an unsaturated solution, which means you can still get more solute, and the solute is the red dots. You can still get more solute into this solution. This right here, the second one, is considered a saturated solution. And a saturated solution means that you can get no more solute to dissolve. In fact, you can tell that there's no more solute able to dissolve because you have a precipitate at the bottom. And a precipitate just means you have leftover solute at the bottom. You've seen this before if you've tried to dissolve an excess amount of sugar, like in a sweet tea or something, or in your coffee. And then finally, you have a supersaturated solution. A supersaturated solution is when you have an excess of solute that is dissolved in the liquid. Now, table G explains solubility in water, and all of these values are for 100 grams of water. So if you're ever given a Regents question and it asks you for 50 grams of water, you have to take this number that you get and you have to divide it by 2. If it asks you in 200 grams of water, you have to take this number and multiply it by 2. Keep that in mind because they will try to trick you on the Regents. Now, let's look at this graph. This graph is a little bit confusing, but there's a lot of information on here. And all I'm going to do is I'm going to look at one value in particular, and I'm going to be looking at the numbers for potassium nitrate. And this is the solubility of potassium nitrate. So as you increase the temperature, you're increasing the amount of solute that can dissolve in 100 grams of water. So let's look at this. At 30 degrees Celsius, I can get approximately 47 grams of potassium nitrate to dissolve to form a saturated solution. Now, as I heat it up to 60 degrees, I can get quite a bit more. In fact, I can get about 105 grams of potassium nitrate to dissolve at 60 degrees. And I can get 47 to dissolve at 30 degrees, I'm sorry. So what this is telling me is if I were to heat this up, I'm going to get more and more and more potassium nitrate to dissolve. But what this is also telling me is if I cool this down, if I start at 60 degrees and I have a saturated solution, which by the way, this line indicates the saturation level for potassium nitrate, I cannot get any more potassium nitrate to dissolve at 60 degrees. I can only get about 105 grams to dissolve. So if I had 105 grams of potassium nitrate in 100 grams of water, and I cooled it down to 30 degrees, I would have about 60 grams, a little less than 60, maybe 58 grams of potassium nitrate would actually come out of solution. So that would actually precipitate onto the bottom. So what would happen is I would have a saturated solution, I cool it down, and I would get an additional 60 grams of potassium nitrate that would form on the bottom. That is the information that I can get from this graph. So let's look at a couple of other things. So a typical question that they're going to ask is they're going to ask you something like, if I had 80 grams of solute dissolved in 100 grams of water at 20 degrees Celsius, and there was a question that asked for which solute would this be unsaturated? So what that means is this dot, for it to be unsaturated, it has to be underneath a line. So at 80 grams of solute is underneath two of these lines. It's actually underneath the line for sodium nitrate, and it's also under the line for potassium iodide. So for sodium nitrate, 80 grams would make an unsaturated solution. For potassium iodide, 80 grams would make an unsaturated solution. But for every other compound, for example, hydrogen chloride, potassium nitrate, ammonium chloride, ammonia, these are all supersaturated solutions. Here's a question. If you have 80 grams of solute dissolved in 100 grams of water at 10 degrees Celsius and it forms a saturated solution, what is the identity of the solute? How do you solve this? Again, 80 grams of solute. So let's go ahead and draw a line on 80. At 10 degrees Celsius. And I asked you, and I told you it was forming a saturated solution. What is the identity of that solute? So what you're going to do is you're going to figure out where 80 and 10 meet, and you're going to look on that graph, and since I said saturated, that point where these lines meet has to be on one of these lines. So this meeting point is actually on the graph for sodium nitrate. So at 10 degrees Celsius and 80 grams of solute, sodium nitrate would form a saturated solution. Here's one more question. If I have 60 grams of solute, in fact, I have 60 grams of potassium nitrate at 60 degrees Celsius. So 60 grams of potassium nitrate. Remember, potassium nitrate is this line right here. So I have 60 grams of potassium nitrate at 60 degrees Celsius. How many more grams of potassium nitrate can dissolve in solution before it forms a saturated solution? So what I do is I'm going to connect this line, this starting point, and I'm going to go up to where it meets the line. And I'm going to figure out this difference. So I started at 60, and I ended up at 105 grams. What is the difference between 60 and 105 grams? It's 55 grams. So if I have 60 grams of potassium nitrate at 60 degrees Celsius, I can still dissolve 55 more grams of potassium nitrate before it forms a saturated solution. Okay? These are a few of the examples that you're going to be quizzed upon on the Regents. Pay attention to this. Look at this practice problem right here. Good luck.